Alright, there's a force in the universe that is strong. And no, it's not Anakin Skywalker. It's actually black holes. Today, I'll be discussing with you the physics behind black holes. I'll give you a brief explanation to what black holes are, what happens if you fall into a black hole, and some other random facts along the way. I've been fascinated with the universe since a very young age. I watch documentaries, I've listened to professors speak on it even though I wasn't even in the class. I've even done term papers on the universe. It's just something that I was fascinated with. And black holes really appeal to me because it's something that we don't know much about, and yet we speculate about them. Today, I'll try to use a simple analogy to explain to you what a black hole is, in order to show the complexity behind it. So, a black hole is a point in the universe where there's an overwhelming amount of matter, or simply put, just stuff. This is kind of like my closet when I was young. When my mom would tell me to clean my room, I'd pick up all my toys and all my junk and just throw it in my closet so it seemed like I had a clean room. In space, in the universe, a black hole is kind of like this. A black hole is essentially when a giant star dies. You have all this stuff that the star was originally made of, now compressed into a very small point. What happens at this point is the stuff has so much gravity that it tracks everything around it. Particles that are floating in space, or even things as large as it originally was, stars and planets. This is kind of like what my mom told me to do, was clean my room again, and I would just grab all my stuff and throw it back in my closet. The matter would be sucked into the black hole, essentially. The black hole never grows no matter how much it absorbs. And unfortunately, my closet didn't grow, and it eventually filled up. So a black hole is just a point in space where there's a bunch of stuff being attracted to it. And that's a basic description of it. So now that you have a basic understanding of it, I'd like to move on to my favorite aspect of black holes, which is what would happen if you fell into one. Stephen Hawking, as many of you may know, is a renowned astrologist and physicist. He describes the process of falling into black holes as spaghettification. As you can tell by the term, it doesn't sound like a very fun process. I'm going to use this piece of silly putty to help you understand what spaghettification is. Spaghettification is also known as the noodle effect. And when you're if anybody's made spaghetti, you kind of like roll out the dough and you pull on it a bit. Well, this is what black holes do to you. Let's say you're traveling to a black hole, and let's say you're just out in space swimming around. Your head will be the leading edge, obviously, as you're approaching the black hole. So, let's represent this ball as your head. It looks more like Snooki's head because it's orange, but... Alright. What would happen is the tip of your head will start to stretch, and the sides start to compress. Your neck, your torso, and arms and legs will eventually follow. And you turn from this nice little shape to this elongated object. As you can tell, this would be a very painful process that none of us would survive. But our bodies aren't made of silly putty, so what would actually happen? Well, your cranium will be ripped from your head, and your neck and your shoulders will probably be dislocated, and you have parts of you floating around being stretched out and obliterated. If you're made of silly putty, I guess it could be fun, but since we're not, it's more like a painful process that none of us would survive. Tim, can you put it up? Now that I've described this process, I'll give you some facts about black holes and what they actually are, and what happens. So, a black hole is actually not black, or so speculates Stephen Hawking. He thinks black holes are actually white. What's funny about this statement, besides the obvious irony, is we can't see black holes. We don't know what they look like. We can only see their interaction with other objects. This picture demonstrates that. As you can see in the first frame, you can't really see anything that the matter is being attracted to. As it moves around, you kind of see this hole starting to form, hence why we call it a black hole. But Stephen Hawking speculates that black holes are actually white because as the matter gets closer to the center, it heats up, creating a white-hot center. Secondly, I like to, excuse me for a moment. I'd like to show you that black holes are actually found at the center of every galaxy, even our own Milky Way. Tim? So, if you don't know, our own Milky Way galaxy is about 10,000 light years across. We're about right here, which is about 7,000 light years from the center. And right here is a black hole. Scientists don't know why black holes are found at the center of every galaxy. They can only speculate that the reason why they're a spiral form is because of this black hole. They don't know exactly why they're there. Finally, Tim, please. There's a few things that can escape from a black hole. As particles get attracted to the center, turning white hot, they emit X-rays. X-rays here on Earth are used to detect problems inside ourselves, broken bones, things of that nature. X-rays and gamma rays are emitted from this hot matter towards the center of the black hole. And the Hubble telescope can actually pick this up and show scientists where black holes are. That's another way we discover and monitor black holes. Today I've explained to you what a black hole is, what happens if you fall into a black hole, and some other random facts. I hope I've inspired you to dive into your exploration of black holes more, but don't literally go diving into black holes because, as I said, it's a very painful process. And thank you for your time.
So, Susanna, what did you think?
I thought the instruction was pretty good. It was a pretty good setup. He seemed very intrigued in the topic, and he was very interested in it, which made the audience connected with him and made us also interested in what he was talking about. I thought he did really good with keeping us interested and connected, and his visual aids were very helpful. Kept us laughing. I thought that was good. And he seemed very comfortable up there, so there was no tension between him and us. And he described his visual aids really well.
Okay. Yeah, I like the dramatic statement at the beginning and the little joke that you've got. You've got a clear statement of what your topic is. You've got some personal explanation about why you're talking about the subject, and then there's a good setup of what your goal is, and you've got a preview. The first point was signposted very clearly, and the analogy that you use is kind of fun, and everybody can relate to it and understand what you're talking about. I did think a little bit about how if your closet actually does fill up, how is it that a black hole can't fill up? And I thought maybe I could use a little bit more explanation on those sorts of things, but I like the idea that you use to explain it. There's a nice summary and transition to the next point also. You have that fun demonstration of spaghettification using the silly putty with a nice gruesome description, so everybody will be, thinking about that one later on and worrying about black holes running into them during the day, because they certainly don't want anything like that to happen to them. The third point just seemed like it was a collection of random information, and I think it needed a little bit more structure to it. And sometimes the information seemed to be a little bit confusing. I had always heard that there was nothing that could escape a black hole, and then you're telling me that there are things that could escape, so I needed a little bit more clarity on that kind of thing. I got citations from Stephen Hawking a couple of times, but other than that, I didn't really think you did enough citing the information that you had. I did want you to put the silly putty down after you were finished discussing it, and you kind of kept it in your hands and played with it during the speech, and I think that that's a little bit of a distraction. The first slide that you had with the 6 sections on it, I didn't really understand what you were explaining there. I don't think that it added anything to the presentation. On the later ones, though, I thought you did a pretty good job explaining maybe how black holes at the center of the galaxy or the universe tends to, maybe explain the spiral movement of those galaxies. I thought that was an interesting idea there. And the nice part about it is that you always try to present it in a way that will keep the audience interested. You've got an analogy, kind of a funny story, a way to relate to it, simplification of an idea, and I thought that seemed to really take into account the nature of the subject and the audience very effectively. All right, thank you.